Alrighty, objective 1, function notation. For this part of the introduction of functions and notation and all what that means, I care about three things. Please take a moment to write down function notation and f of x equals 3x minus 4, and then find f of negative 3. The given function f of x equals 3x minus 4, and I want you to find f of negative 3. Now we're not actually going to evaluate this function, that's going to come later, but I want you to be able to at least identify very, very important pieces of any function that you might be given. And then in a little bit, also being able to at least recognize the relationship between x and y, input and output, and to rewrite different forms. That's not necessarily as big today, but it's still very important to see the relationship between x and y. Now, back to f of x equals 3x minus 4, a given function. Hopefully by the end of this video, you'll be able to identify these pieces for any function that you're given. The first piece that I care about is the actual function itself. So I'm going to write out function. The second piece I care about is called the input. And the third piece, maybe you've guessed it by now, is called the output. So, of the three pieces, if I was to look at f of x equals 3x minus 4, I need to know what the function is. The function is the piece that holds, I guess, the input. Because you're going to put it inside the function, and then the function is going to spit it out and give me my output. So the function itself I will identify in the color green. I'm going to box in, this time this function is the linear equation of 3x minus 4. A function will not always be an expression, a linear expression, 3x minus 4. Not always be an expression, it might be a graph, or just a different form. So a form of a graph, a form of a table, but in this case it's just 3x minus 4. So I'm going to identify that as such, 3x minus 4. That is the function. The input then, the input is the piece that you're going to put into the function to give me an output. The input I'll identify in purple. The input is whatever x is, the variable x. So I'm going to draw an arrow and put x value. So the input is always the x values. Always the x-axis if it's on a graph, the x values, or in the corner point, the first point listed, the x value. And in this case, if it's worded like this, which it is, it says find f of negative 3, they're wanting to input negative 3 into this function to give me a specific output. So in this case, my input is negative 3. Now again, I'm not going to actually evaluate that. That's going to come back later. But as long as you can identify that negative 3, the f of negative 3, that's how you say that as well. Sorry, I didn't say that, but f of x, in this case it's f of negative 3. Of negative 3 is the input. And finally, the output is whatever that's going to equal if we actually did the math. But in this case, the output is special because it can be written two ways. It can be written as f of x, g of x, h of x, z of x, it doesn't matter, a letter of x. In that, f of x also equals the more common variable, y. So again, input is x values, x-axis, output is y values, y-axis. And that's, it's very important to notify that this, anytime if the function is written as f of x equals 3x minus 4, it can also be written as, I'll put it up here, y equals 3x minus 4, where x is the input, y is the output. So that's the notation. Hopefully you'll be able to identify all three of those pieces all the time. The relationship between input and output is very specific and very important. They go hand in hand. Anytime there's an input, there will always be an output, and vice versa. If you find one, you can always find the other. You've worked with this throughout middle school and then Algebra 1 and even in geometry. I just want to notify a very important piece to recognize. Hopefully XY coordinate points, like example 1 right here, you're able to recognize pretty quickly. And you're hopefully able to recognize that the first number given is always the x value, and the second is always the y. And this is still part of objective 1. This is part 2 though, being able to rewrite forms from coordinate point form like number 1 and 2 to function notation back into coordinate points. So if I'm given an x and a y, all I hope that you'll be able to recognize eventually after we practice functions for a while is that the input, f of something equals the output. And again, the input is the x value. So in this case, it's f of -6 equals the output, the y value, which is 5. So if I want to rewrite from coordinate point to function notation, this is the answer for function notation. Number 2, the same thing. 0 is my x value, y is my 4 is my y value. This is a coordinate point, so on a graph I could plot 0, 4, but another way you're going to see a lot in this semester is that if it was written f of 0 equals 4, you need to know that this is the x value or the input and this is the y value or the output. And then vice versa, if given function notation, hopefully you're able to see the relationship that the input, I can label here, please be taking these notes, is the x value. And the output is the y value. So if I were to put this in a coordinate point form, it would be 4, -3. That is huge. You're going to see that the entire semester, so that is very important that you understand the relationship between inputs and outputs, x values and y values. And finally over here, the input right here is 2 and my output right here is 5. Now going back to the warm-up, hopefully now if given any piece of any form of a function, you'd be able to label an input, an output, and the function itself. So if I were to re-venture back to my warm-up, we've already filled out most of this. Number 1, y equals 2x plus 3. That is a function, that's an equation. They're asking for what y is. Y, we just talked about, is my output. Let's go ahead and fill out what else we know. 2x plus 3, a box, that is the function itself. And x, in this case, is the input. That is the goal of this entire objective 1, that if you're given something like that, you can begin to see, oh, x value, whatever I put into x is the input, output is the y value, and the expression is the function. Over here, it's asking, what is 3? In this case, that's the x value or the input, which means 5 is the output. And then numbers 3 and 4, we've already talked about a little bit, but I just want to make sure this is hammered home. I've circled g of x. What are those values? Those values we've talked about in table form. This is the x on the left side. You're going to input something on the table form, and you're going to output the g of x. Remember we said f of x, g of x, z of x, I don't care what it is, that also equals y. So I can make note that that also equals y. My y values are my outputs, which means these are my inputs. And then finally, I've drawn the graph of this table. So we wanted to know, what is the actual graph? The graph is the function. A function can be displayed in many different forms. It can be displayed graphically, it can be written as the expression, and 2x plus 3 these are points that are found on the graph, and this is the graph y equals 2x plus 3. So hopefully you'd be able, if given a graph, you know that that is the actual function that is graphed. If I input -1, I can go over from the origin 0, 0, right here. I can go over -1 and up 1. And holy moly, it's there. If I input 2, over to 2 from the origin, right here and up to 7, it's there. And if I input 4, it's going to be off the chart, but it'll be up to 11, it's right there. Input outputs, x and y values. Now it's time to practice a little bit.